Good morning, good afternoon, good evening, and welcome to a special edition of Red Hat Live Streaming. I am joined by Ortwin and Benjamin, two fellow Red Hatters. Today we are showing off something they call Bobbycar. So I'm super curious to see, I know the backstory. Trust me, you will all appreciate this and enjoy this. I'd like to just quickly, let's do a round of intros and then dive in. Benjamin, please feel free to introduce yourself. Tell us what you do here at Red Hat.
Yeah, thanks, Chris. I'm Benjamin. I joined Red Hat 2019 as a solution architect for application services. In the meantime, I've transferred into another role, into an account solution architect for the public healthcare in Germany.
Ooh.
So yeah, I have a long development background. Before I joined Red Hat, I worked in the development role. The Bobbycar demo was a nice recap of all the development things and all that stuff. So yeah, that's to my person. I will hand over to Ortwin now.
Yeah, thank you, Benjamin. Yeah, my name is Ortwin Schneider. I'm domain solution architect at Red Hat, also in Germany, but for the responsible, let's say, for the manufacturing industry there. And I have a lot of automotive customers. So Bobbycar was quite close to what I do in my normal job, so to say. And it is one reason why we've created this demo as well. Yeah, from my background, I've started as a Java developer, but I'm, let's say, today quite a bit away from really engineering. This is kind of just for fun stuff. I've done a lot of people management before Red Hat, and I've also joined in 2019 Red Hat, like Benjamin, and we know each other since, I think 2005. So we have a lot of projects done together, and we're kind of the former dream team as well. So it's cool that he's also at Red Hat, and it's great to be here. Yeah. I'd like today. I think we have, let's say, two parts today. So we'd like to present the demo, which is kind of a multi-product demo based on Openshift in this context of edge computing, IoT, connected vehicles, and so on. And the second part of it is more the development story. So how could you develop for this Bobbycar demo? How could you extend it and so on? So this is kind of what we've prepared. And to give you some kind of context, I would start with a little bit of slides to just get you into what it's all about, and then we switch to the demo parts. And I've always a little bit of slides and then demo parts. So I'd like to start with the screen sharing then. Let me just...
Yes, the screen sharing gods smile upon you.
This is great. I see the black screen still now.
You got it.
Great.
All good.
Yeah, okay, cool. So yeah, first just some Orga stuff. So if you have any questions after this session regarding the demo, here you find our contact data. And there is, of course, the GitHub repository where you can have a look into. There's all the code lying there. There's also an Helm chart repository as well. Another thing here is I've written an ebook chapter with Markus Eisele. I think a lot of guys know him as well. It is about cloud native IoT architecture, and that was one chapter for this ebook. And there's also a blog post where it's about Bobbycar and building cloud native IoT solutions. So just if you need some additional information there. And yeah, from here, what I would like to start then with a project, Bobbycar. What is it? What is it about? And so on. So if you would describe it in one sentence, it's microservice-based cloud-native application and a smart IoT transportation demo, which really highlights Openshift and a lot of the Red Hat middleware stack we have in a business-relevant context. And this is important. So one aspect or one thing from the background was we wanted to not only show individual technologies, right? So like API management or messaging or whatever. We want to bring all the stuff Red Hat has together and make it work together in a meaningful context. So that was one thing. The other thing, as I've mentioned, I have a lot to do with automotive customers and IoT and edge, let's say, architectures in this industrial edge as well as vehicle edge. And so it would be, or I thought it would be a great idea to build a demo with all the capabilities we have in this context as well. So you could consider Bobbycar also as let's say a subset of an IoT reference architecture. So for example, example, if you look at Azure or AWS, what they have kind of in the reference architecture, what components, this is kind of an example where you could see, okay, these are the components we have from Red Hat, and we can build those architectures as well with open source technology. So you can consider it like this. And then Bobbycar, I'm not sure, in Germany, at least, everybody knows what a Bobbycar is. These
right.
You see it on a picture, right? These little red is the original color. These cars where your kids sit there and push with the feet, and they drive like crazy. They drive you like crazy, and you have to kind of control them. So it is about car simulation, the demo. So we have cars, and the color, yeah, it fits quite nice with our Red Hat color. So this is why we came to Bobbycar, and this is quite cool. So.
And the difference is they are cloud native Bobbycars, right? In this scenario.
Not to be confused with sidecars or the racing cars, which I thought was hilarious that these things actually get raced. It's like, of course they get raced. It's a car. Of course it would be a racing vehicle. Please go ahead.
Yeah, so for this demo, there are basically two core concepts. So as mentioned, there are the Bobbycars, and then we have Bobbycar zones. And Bobbycars are actually vehicle simulators, and we have implemented them in Quarkus, let's say our cloud native Java stack. And we've used a lot of extensions there, like reactive messaging and metrics and some of the stuff Quarkus offers. And we also simulate with one container multiple Bobbycars. So one thread of the container is actually simulating one car. And this is in our demo, or it represents really the vehicle or the edge tier. And basically how it works is when we start the simulation, one Bobbycar picks, let's say, a random route from a pool of routes. This is in a GPX format at startup, and it kind of simulates driving from start to end. And while driving, it sends telemetry data to an IoT cloud gateway, like the current GPS position, speed, RPM, fuel consumption, and so on. And we've also made it a little bit configurable in terms of that we've taken real or gear ratios, for example, from real cars, and you could also configure different driving strategies, things like this. So this is kind of the core, our Quarkus application, the vehicle simulator, which is the Bobbycar. And the second thing is the Bobbycar zone, which is a geographical zone with a certain type, like a circle or a rectangle or something. So you can specify an area where you want to define specific, let's say, for example, mobility services you want to get deployed to the car. So when a car enters this zone, you want either to deploy, let's say, a specific configuration which is valid for the zone, or specific mobility services which are relevant in this environment. So this is kind of this concept of a zone. And then you have also things like priorities and rules and what is when overlapping and so on. But these are basically the two things. And yeah, from an implementation perspective, we've implemented them as Kubernetes custom resources. So you could also then, of course, for example, with a GitOps approach, create new zones in a declarative approach. And from the high-level architecture, it looks like this. So we have on the left side our, let's say, the edge tier, where we have the Bobbycars, and we can scale them up and down and can use all the benefits of what Quarkus offers. And then we have several regional IoT clouds. By the way, everything is running in Openshift in our case, also the Bobbycars. So we have kind of the cloud environment then, where the Bobbycars are connected to over MQTT, for example. So they send the metrics over MQTT to a Kafka broker. So everything we get in is running into Kafka, which is really our high throughput streaming platform, or the central point for the data ingestion. Then we have distributed in memory cache, the data grid, where we kind of store all the recent updates of all the metrics, all the cars, all the configurations we have in this distributed cache, and for reasons of performance. So we want to be able to kind of restore the complete IoT state within milliseconds, for example. And this is also a pattern we often see at customers and so on. And these little boxes here are basically integrations. So for example, from MQTT to Kafka, Kafka to data grid, and so on, or exposing data as per WebSocket to a dashboard. There we used Apache Camel K, so also the cloud native integration components there. And yeah, this is kind of the regional cloud environment. And from there, we use the Kafka Mirror Maker technology to replicate the data to a central cloud environment where all the data is coming then from all the, let's say, local cloud environments. And there we could use, for example, with Open Data Hub, TensorFlow, IO, we use some machine learning technologies to really work on the data coming in here. And this is kind of the high level how it looks like, the architecture. I mean, there's a lot of more details, but I think this is to just give you the idea how the setup looks like. And yeah, with this, I would come to the first part of this demo. So let's say this is kind of the core demo then. And there we want to show two things, like I've just mentioned. So the one thing is this, all these connected cars, how are they connected? How does it look like? And the second thing is, how do we apply location-based configurations, right? So these are basically the two core things. And therefore, we kind of zoom into this regional IoT cloud environment, because this is what we've actually have in this demonstration. We've created this one. And there we have the Bobbycars with all the possibilities to configure them with driving strategies, with specific configurations and so on. And what they actually do is they send the GPS data over a Kafka bridge over HTTP to Kafka then, and the metrics, they go over the MQTT broker to Kafka. All the components here are the Camel K components. So there's one MQTT to Kafka. There is one dashboard service exposing the data from Kafka for a real-time dashboard. There is a zone change detection service and a data or a service which is transferring the data to the cache. And so whenever there's a zone change, for example, there will be an event emitted, which is sent to MQTT, and the cars are subscribing to certain topics there, getting the event, and pulling the actual configuration in case it is a configuration from a cache. So all the information is in the cache, so there's a cache API service as well, and they're pulling the information in. So this is basically the architecture. And with this, I would directly jump then in the first part of the demo and just show you what you've seen here on the slides. So therefore, I go to my Openshift environment, and you see I have a quite current, at least it is a 4.7. It's not 4.
Right. No, 4.8. I mean, it literally came out last week. So, you know. Yeah,
so I'm not.
It feels like it. Yeah.
But it's quite current. So 4.7. OpenShift environment here, and there is a project, Bobbycar. So this is our Bobbycar project here, and we've deployed all the stuff you've just seen. So all the regional IoT cloud stuff in this namespace. Let me just switch to the developer perspective here, and we should see then the topology. So you see all the stuff right here. Here's the Kafka cluster, for example, running. Here's the Kafka bridge running. We have the several operators there. Here we have the Camel K integrations, for example, this Kafka to data grid integration and so on, caching service. And here is actually the car simulator, our Bobbycar. And you see there's one pod currently running. And this one pod, it is configured that it simulates 20 cars right now. And there is a dashboard component. This is an Angular component. We will have a look right just in a second there. So this is kind of all the stuff. In case of you want to deploy it by yourself, you go to the GitHub repo and want to deploy the stuff. In general, we have packaged them as Helm charts. So for example, if you go to just here at project, Helm charts, for example, and you see here, I've customized the Helm chart repo with the Bobbycar repo, and you see all the Helm charts for Bobbycar then here, and you could very easily deploy them from here. So there are some core charts, like for the operators, infra, and the apps. These three are kind of combined the core demo. And then we have optional things, like if you want to show or showcase development, you can install the optionals, right? So this is, I think I really like that it's so cool integrated into the console of OpenShift, and yeah, very easy to do. I mean,
you just have to add the repo, right?
Yeah, here, just
the Helm chart repo.
Yeah, it's very easy, right? So you just specify in this custom resource your Helm chart repo, and it will pop up in the console. So quite nice. Yeah, then let's just have a look now in the dashboard, because this is, let's say, the only thing where we have kind of a visualization. All the other stuff is a lot of data transferring and not so visual. So we've created a dashboard. This is our dashboard component, and as mentioned, the Angular application. And basically, what we have is one map view. So this is our map view, and you see, okay, or you should see these red circles here. We are currently in Germany. This is Frankfurt, and every red circle here is kind of a Bobbycar zone, right? So whenever a car enters a zone, it will get some configuration then. Our cars are driving right here. So I'm not sure if you see that they're actually moving. Yeah? So you should see some moving markers here that the cars are driving right there. And yeah, we have the different zones. And now one thing we could do is, for example, create new zones from here. This is creating new zones and specifying this is the location and so on. I won't do it. I mean, you get the idea what you could do with it. And yeah, another interesting thing here is also this let's say real-time query. What we want to do is, sorry.
Just see dots moving, and that makes me happy. So yeah, I like to see real-time data coming in here.
Yeah, so basically these are the 20 cars, and they're sending the data to MQTT to Kafka to WebSocket to this dashboard, right? So this is kind of the data flow here, which you see. Yeah, by the way,
and the first time you open this this map, it will load all the data from the cache. So the cache contains the current snapshot, right?
Right.
Yeah. So for example, also if let's say I reset the map, so you will see that it directly get the latest state and restored here, right? And then it gets the updates over the WebSocket coming in from the, let's say, real-time data there. You see here we have some cars entering the zone. Let me see if we can hit this one. So if I select this car, and you should see, okay, it's driving here now, and you see the zone change event, right? So there was the zone change event directly now. This is kind of the detail view. Now I just select one car. In this case, it's a Volkswagen, but this is just a gimmick to, let's say, switch the cockpits like in BMW or Mercedes or whatever you like. So depending on the sponsor we have, we can adjust that. And there is kind of a heads-up display where you also see now the metrics for this car, how fast is it going, and so on, and what type of car is it, and what is the current zone the car is in, and so on. And yeah, so you see it's arriving in the next zone here. And yeah, probably we just wait a few seconds to see again the zone change. And if it's successful, we should also see here the actual zone, or the new zone then. Okay, it's in there, and you see it's applied also in the car now. We have this Niedernhausen zone, so it's yeah, working at this stage. Yeah, that was one thing. So you can have a look at the cars and can see, okay, is everything running the right way? The other thing was this real-time query. If I'm interested in, for example, a certain area and want to know or want to see what is the real-time data of a certain area here. So I have kind of this gray circle, which is like my search environment, and I can say, okay, I'm interested in all the cars driving here, and I want to have what is the average speed, I don't know, carbon dioxide emission, and so on. And the driver distraction thing, I'll come to this later, because this is kind of a machine learning use case in this context. Okay. And then we can kind of start or execute an interactive query to the Kafka stream, right? So to the state and get for all the cars in here, let's say the current data then, right? So we query kind of the internal state of the Kafka streams application. So this is kind of a real-time query aggregation thing, which is also quite nice because we wanted then, if we in later on, if we extend the demo, then we wanted to, for example, if there are certain thresholds and exceeded, right? So we want to, for example, automatically then create certain zones for this area to specify the maximum, for example, speed limit or something, right? So to react on this data then.
Otwin, do we have Street View data?
Okay.
Because we didn't see that. No.
Here, yeah. This is quite nice. Let me check here. A car detail. Yeah, you see it here. Right. If there's Street View data available, so this car is kind of driving like crazy.
I was about to say, like, there's a lot of different angles here. Now it looks good. Okay.
Takes some time.
Yeah.
Okay. Yeah. Okay. It's kind of driving backward. Oh, okay. Yeah, but
live demo.
Yeah, I was about to say, it seems like it doesn't understand what elevation it's at or something. Yeah.
Okay.
Where can I buy this car?
Where can I buy my shape-shifting auto transporting car?
Right. Yeah, probably one other thing also. So for the car simulator, maybe one thing, you see this is one pod. You could then specify through environments like, let me just show you in a second here, environments. So you see here, like we have specified 20 cars for car sim, right? And then you can also specify things like how fast should the simulation run? So 3 times or the simulation factor, you can configure it here as well. And also delays and other things like connectivity to MQTT, Kafka, and things like this. And yeah, so that's one thing. The other thing, let me switch back to the pod. Where's my actual pod? No, I wanted not the pod, sorry, the route for the car simulator. Where is my car simulator here? We have also some custom metrics as well, because this is one thing we also wanted to show to if you want to then integrate it into monitoring, right? So, and want to scrape it with Prometheus and so on, and you want to have all these data here. So here you see for the cars running currently, right? All the Prometheus, all the custom metrics we have implemented there. And yeah, that's one thing. And probably I've almost
you wanted to scale, Odwin,
right? Okay, right. We could just let it scale. Why not? So that was one car, and I said one pod is simulating 20 cars. Let's scale it a little bit up and see what's happening then. So let's go to the car simulator and here details. I do it in the console. So 2 pods, 3, 4. 5 pods, should be 100 cars. And first of all, we should see that the Quarkus pods, there
you go.
They're up and running. And if we now go back to the map, we see here in the headline that the new cars are coming. So we have 45, 50, and you can configure a delay. I think there is a 1 second delay before the next car is coming and so on. So you see the new cars dropping in the map, and now we should have the 100 cars. Yeah, and we're good to go with 100. Yeah, and this way, and with Quarkus, I think Quarkus is quite nice because of the high density, and you could very easily also scale to thousands of cars and simulate it that way, and also like auto scale the other infrastructure in Openshift, and a lot of the things you can scale really automatic. So this is a cool architecture, so to say. But that was, let's say, the first part of the demo, like the core demo. We have the cars, we have a certain look at it, a real-time query feature, and with that, I would just jump back to, I think, some slides for the second part, and then we jump in the next demo part. By the way, let me just share you these 2 slides. because it is not only a demo. So currently I'm working with two partners really on real world use cases, right? And one of it is over-the-air updates with eSync Alliance. And for those of you who don't know eSync Alliance in automotive, this is kind of a new kind of standard protocol, standard technologies on how over-the-air updates for vehicles can be implemented. And there are a lot of also automotive companies in that. And basically the architecture is there's an eSync server component, right, where you can plan your campaigns, for example, to update firmware of your ECUs in the car and so on. So there's a server component running in the cloud environment. And then in the car, there's a eSync client, which is kind of the IoT gateway, so to say, right? This is a gateway component connected, and connected to this gateway component, we have all the different ECUs, right? And you can now update ECUs, the client components, and the car components through this architecture. And currently I'm working on it. I have a running eSync server in this Openshift environment. And what we want to do in the context also of Bobbycar is that whenever a car enters a zone, we want to update the car configuration with this eSync architecture, right? With this, what is industry standard for over-the-air updates. So this is in the context of Bobbycar. And the other use case, also quite nice with a partner, with a great partner entity, is kind of we're building, like we've called it, the human driving perception platform. And this is kind of, it is about, capturing the driver's emotion. And so there's this emotional detection, and combine it with the data from the CAN bus we get from the car, right? From all the CAN data from the ECUs, and combine it and to really calculate, like, or to see, okay, what is the driver distraction at a certain point, right? And how is it? How does it relate with the current data we get from the CAN buses and from the ECUs? And then calculate in the first step something like a vehicle collision risk. And other things like, why is the driver distraction, for example, very high in a certain area or at a specific street corner and so on, and to do some machine learning with this data. So this is kind of, let's say, also a new thing, because normally in the real world, they don't have this emotional recognition and combine it with the other data available, right? So, and this is a use case we built in this Bobbycar. And yeah, let me just show you some of these components as well. So go away. Okay, here. So we're back in our Openshift cluster, and what I like to do here is, just a second, there is this HDPP, Human Driving Perception Platform. So what you see here are two containers, or two pods, two deployments actually. And one is the actual application. So both of these components are running normally in the vehicle, right? So, and this is the application. There's a Python application with OpenCV, TensorFlow, and some of the machine learning libraries. And here's kind of the execution of the machine learning model running in this container, right? And there's also currently, we get the data, there's a pretty huge PVC where we have all the video data lying, all the CAN data, and so on, millions of data sets for the CAN bus, from the CAN bus and so on. And now let me scale this one up. So this is the actual execution of the machine learning, doing all the real-time calculation. And then it's sending all the data to this cloud gateway. So this is kind of a standard component, an IoT gateway. And this one, these two components run in the car. And this gateway is then connected to the Bobbycar, let's say, infrastructure. And the communication protocol is also MQTT, but there are some standard messages, and there's a specification for this component. So this gateway is connected. Then I've implemented a little bit, let's say something like a device registry. Let me just check. It is here. So this is a Quarkus application as well. So it has a REST API. And here you can really onboard new IoT gateways from in the car, right? So you can, it uses a MongoDB. And then if you have done the registration process, the data goes then over MQTT and then to Kafka and to the other Bobbycar infrastructure. So this is kind of what we have here. Let me just show you the REST API. There is a Swagger UI. So you see, okay, this is some APIs to register gateways and IoT gateways and so on. So this is little thing I've implemented there. And now, okay, if we go back to the Bobbycar dashboard, now it should be up and running, our actual machine learning application. So the story is from here, right? So we are in this cockpit view. And from here, we want now to see, okay, we want to capture the emotional recognition. So let us see if it's working. So this is kind of now streaming. Yeah, you see it's running. Now everything you see here, the stream is coming from this container, from the in-car, and all the calculations and everything is now running kind of in real time, what you see here. And yeah, you see kind of the driver. We have two cameras, the inside camera and outside camera. And you see, okay, it detects what is outside. How's the driver reacting? It calculates a driver reaction and a driver distraction and the vehicle collision risk. And all these three components down here, they are then sent through the backend to the Bobbycar, to Kafka and so on, to do further machine learning logic then there. So this is kind of the working state of this POC.
I could see how this could be so helpful in training for that distraction kind of ML thing, which, to be honest with you, I feel like is going to come to every car at some point, right? Like it's just a matter of time.
Right.
I mean, even my like 2020 Ford Escape has some capability to realize what I'm doing in the car, right? Like it recognizes there's a human of a certain weight class sitting in the seat, so it'll actually go, you know, that kind of stuff.
Right.
It's only a matter of time until this becomes just normal, right?
Right. So yeah, but it's great. I mean, you can see all the components are running in OpenShift. You can do all the simulations there. You can use OpenShift, the complete stack, to for everything, right? So for the cloud backend infrastructure, for simulating, let's say the vehicle edge as well, and so on. And yeah, it's cool. So that was just to show you there are also some real world use cases we're working on in this context. And I think the next step would be then, I think I have some slides, but regarding time, yeah, I have some things.
You have 10 minutes for the slides.
I have 10 minutes. Okay. This is
yeah.
Okay. I think I will really go very short over the slides because I think we should jump into the next demo and proceed. But from the storyline, you know, the car simulator is Quarkus, and now, so why Quarkus, and what is the cool story about Quarkus? I mean, Quarkus is cloud native Java stack. So the message here is, everybody who is a Java developer, he should have a look, or he or she should have a look into Quarkus, because it's really, really great. Java is a language which is quite old, I think now 26 years or something. And the way back then, we didn't have containers or Kubernetes or like the cloud native world we are in today. So Java was mainly, you've written more or less monolithic applications, right, for application servers and so on. And the challenge with Java really in this modern environment we are today is in terms of resource consumptions, memory consumption, and also startup times. And this is exactly what Quarkus addresses there, and rethinks the way we use or can use Quarkus in new modern approaches of also architectures, like in serverless or even smaller function as a service and things like this. And basically the idea what Quarkus does is it does kind of 80% of the work at build time, right? And as less as possible at runtime. And so Quarkus is kind of a framework, or the extension framework is a framework for other frameworks which kick in at build time. So it's kind of a cool thing. Basically, it tries to optimize everything which is possible at build time, and it uses the Graal VM to be able to compile the code natively as well, so to compile into machine code, to have really very fast startup times and so on. So I think this picture is quite nice there, and this leads then also. So Quarkus is great technology for a cloud native Java stack, for serverless, for microservices, and so on. And this is also why it's great for serverless. And serverless is, as you know, now in this Bobbycar context, we're handling with a lot of events. Basically, it's an event-driven architecture, like every IoT or edge architecture. So all the things that the cars emit are kind of events. And this is kind of a great foundation to use events like in an event-driven system and in a serverless context to really scale by demand, scale to zero, use all the serverless features there, right? And for the implementation, Quarkus is a great option right now, as it's really fast startup times, what you need in this context, right? And also a low resource footprint. And yeah, so just I have a few slides regarding serverless. The basic pattern is like you have some kind of events, and it could be anything, like it could be an HTTP request, an async Kafka message or something, right? Or an upload to an S3 bucket or whatever. So there's an event, and this triggers kind of your application, and there's the framework, the serverless framework or platform, which is then responsible for scaling your application and obviously producing some more or less sensible result there. So this is the basic pattern. And maybe one slide back, the cool thing is, from our perspective, we can use the complete bunch of Apache Camel, right? So all the components we have as event sources for our serverless platform. So this is cool. So you can integrate almost anything into the serverless world we have here. So this is quite cool. And yeah, from a developer perspective, of course, so serverless kind of adds a new abstraction layer, right? And so from a developer perspective, it is really focusing on the writing your code, your actual business logic, and you push your code, and the platform cares about the rest, like compiling, building, packaging, and dependency resolution, all this stuff, and also the scaling policies. Now, we have OpenShift serverless. This is great. This is also part of the OpenShift platform. And now let's go to the next one. The way is how we use serverless in the Bobbycar context. I think this is interesting. And we have kind of, let me go to the presentation mode. So we have kind of two use cases now. We have this Bobbycar core demo. And what we have is Bobbycar zones, as mentioned, right? So our circuits. And so the one use case is we want to kind of monitor the life cycle of those zones, right? So whenever someone adds a new zone or changes a zone, edits a zone, deletes a zone, we want to trigger, we want, for example, to start an approval process, because in the real world, the Bobbycar zone is a very relevant entity, right? So that could be one reason. So we want to trigger or to start an approval process. And this could be, for example, implemented with Cogito and as an BPM process, for example, or to execute also some decision manager rules or some business rules, things like this. And the other thing is also the zone change events. We want to consume them from Kafka and feed them as cloud events also into our serverless infrastructure. And there we have implemented a Quarkus Funky, let's say, service to react on those events. So these are basically the two things. From the architecture of serverless, it looks like this. So we have kind of these event sources, like for Kafka, and for the API service source, we have a broker sitting here. And then we have our consuming applications, the Knative services, and also some triggers. For example, the approval service will only be triggered when we create a new event, a new Bobbycar zone, right? Yeah, so that's kind of the serverless stack, and let's directly jump into the demo here. So I go to my development environment. By the way, this is kind of the Git repository. If you clone it, there is here you have the components. So all the components you've seen. There's a Helm directory, and here we have all the Helm charts. And I haven't deployed the serverless stack, so this is what we do right now. So there is the serverless Helm chart, and I will just deploy it now into our current Bobbycar namespace. So everything should be running then. We could then switch back. Let me just see if it's actually then deploying the release. Yeah, it should work. Yeah. So let me
just as a reminder, Ortwin, could you please scale down the perception pod?
Oh yeah, this is very, very important, because my cluster is quite limited right now in terms of resources. So let me just, that was the HTTP. I scale it to 0, yeah. So this is the application. Let me just scale it to 0. Okay, now back to our Bobbycar namespace. This is where we just deployed the Helm release. Okay, it's quite confusing.
It has been deployed.
Yeah, so you see exactly the same architecture, right? So the event sources, and you see also here the zone changes. So we currently have, let me see in the dashboard, if we have some cars currently, yeah, so they're entering the zone, a new zone, and you see that there are automatically 3 pods now scaled to handle the zone change events. And depending on the amount of cars entering a zone, I have specified the concurrency for handling these services to 1 so that we see some auto scaling here, right? So you see, okay, there are some zone change pods running automatically, and it will then soon scale them down. And here is our approval service. Now, when it's scaled to 0, we can just create a new Bobbycar zone, and we can then just see how it is triggered, the approval service then, right? Yeah, the audit service is always triggered. So whenever for every change, for example. So yeah, let us just deploy then a new Bobbycar zone. So let's go back to our repository. There is a config. Here is a demo zone. So this is kind of I want to create a new zone without any specific configuration then. This is in Wiesbaden, Germany, a freeway intersection, and I want to specify a zone for this location. So let me just add it directly here, import as YAML, create this zone. Let's go back or go to the developer perspective. Okay, still confusing. Okay. So yeah, but you see, okay, the approval process now, it's scaled up. So this one, this addition triggered then this approval process, and we can also, for example, have a look there in the logs, and you should see there is the Wiesbaden freeway intersection. You see there's the cloud event, right? So all these attributes of the cloud event, and the data is actually, in this case, the complete custom resource of this new one. And this is kind of the input for example, for a business process then, right? Yeah, this is just to kind of give an idea on some of the use cases, how you could use also serverless in this context of Bobbycar. This is just a snippet. I mean, there is a lot more you could really do in the real world in the serverless context. But yeah, so I think hopefully that was a bit helpful.
Oh, it was very enlightening and insightful, trust me. All kinds of ideas are spilling out of my head now, but I'm curious what the audience thinks. If you have any questions, please feel free to ask. You know, how this demo was built, that kind of thing. Feel free. All right.
Fortunately, we will talk about this now.
This is
all the bases covered.
Yeah, so that was kind of, let's say, the core demo parts. So like the core, what is Bobbycar about, a bit of serverless. I mean, there's a lot more in the pipeline, like GitOps deployment, advanced cluster management, and a lot of other things we're currently working on, like also an operator for Bobbycar and so on. But yeah, this is currently the core demo, what it is about. And the second part is now really developer workflow for Bobbycar, right? So, and in the second part, I will put on my hat and I will definitely switch roles now. Yeah, so I'm not Ortwin anymore. I am Mr. Subatomic.
and I'm Carl Native.
And Benjamin is from now on Mr. Carl Native. He's the senior software engineer, and I am the, let's say, director of Bobbycar engineering, and I am the owner of the project. And yeah, I hired Carl Native because he's a great Java software developer, and I want him to extend Bobbycar, right? So, and his job is kind of doing this inner loop development. So I want him to extend the demo, to code, debug, and so on, doing unit tests, all the things a good developer does. And then also the outer loop, if he's finished with his features, he will somehow also need to, we need some continuous delivery, right? So CI/CD is very important here. So this is what his job is, and what I've done is I've sent him just an email with one link to set up his IDE, and I think from here, Carl, you could get started.
I even changed my title.
I saw that. That was very, very slick. Yeah.
So yeah. Thanks, Mr. Subatomic. I've got your email, and I saw that you sent me a link.
Right.
So to follow what I'm doing here, I am just sharing my screen. I hope you can see it now.
Yeah.
Okay, great. Yeah, I've already copied this link into my browser, and as you can see, it points to something in Openshift. Mr. Subatomic mentioned that this is running, or everything which is part of the development environment is running actually again in Openshift.
Right.
So
yeah.
So the host name points to OpenShift, and then I see something like a load factory, maybe a factory to create a workspace, Mr. Subatomic.
Exactly.
Okay, cool, and it points to some file. I will click.
Yeah, just hit the enter button.
Yeah, I'm doing this. Oh, what's happening here? It's initializing a workspace. Wow, this is cool. When every time I've joined a new company, I had to wait a week or more until my actual development environment is ready to use and is actually working. So yeah, let's in the meantime, let's have a look at what I've created here and what this YAML file is all about. I will just make it a bit bigger.
Thank you.
So yeah, I'm looking into that. I'm new. I don't know about this, but it looks like that we have a workspace definition in YAML. Wow, this is really reproducible.
Nice.
I can just send my link and everyone will get the same workspace actually. Wow. And the components, okay, I have several components with several purposes. There's an AMQ, okay. This must have to do something with AMQ. Okay,
yeah,
the
right,
MQTT, right?
But by the way, you have the exact same container image for your development, like for the MQTT broker, like we have in production. So you essentially kind of develop in the production environment.
Wow.
Okay, so I cannot say it works on my machine.
Exactly.
Because okay. Okay, so I see also some plugins. So what we are talking about is a completely new IDE. But I also see VS Code here. I know VS Code. It's a popular development environment. Why is this, Mr.
Yeah, right.
Subatomic?
This Cloud IDE has the same foundation, let's say, like VS Code, and this also gives you the opportunity to use, let's say, most of the VS Code plugins. And you will have a look just in a second, and it looks quite similar. So
okay. And what I also see is that there are some commands that I can run.
Right. You can also pre-configure all the necessary commands. So you don't have to really care about all the things and setting up all the necessary commands for debugging, testing, deployment, sonar scan, whatever. So we can configure everything you need up front. So it should be very easy for you to get started. So this is one of the main ideas here, and to have really to have consistency for all our developers.
Nice. And I see it opened in my browser, and yeah, it also checked out the code. I can see the car simulator. and I'm really curious how this will work out.
Right. Carl, you have now from now on 10 minutes to get really productive, you know.
Oh, okay. True. I give my best. So, okay, this must be the main application. I can open it. I can see syntax highlighting and all that stuff that I expect from an IDE. That's nice. Let's have a look what this dev file, what we've seen, will do for me. Okay, I can see the command. So let's run the car simulator. I click on this command, and it's running. So what it does, it renders logs in my console here. And okay, it's a Maven project, as I can see, and we need to download all the dependencies. Cool. What can I do in the meantime? I see there are several containers that must be the components from the dev file. And let's try AMQ. There's an AMQ link here. I click on it. You promised me that I can use the very same version. So let's have a look if this is true. Wow, it works. No producers, no consumers. Let's see. What else do we have in this project? Application properties. I already know this from Spring Boot and similar frameworks. So we also have this in Quarkus. Let's see here. Okay, Kafka is somehow mocked, I guess. But here, messaging. There are some messaging properties. So let's remove the comments here. It runs here in the same container. So I guess I could do it like this with localhost.
Carl, you're doing amazing, man.
Yeah, but it's still starting, right? So yeah, please. Okay, let me look at the code. What else do we have? Events. Maybe I find the code for publishing the events to MQTT. Okay, nice. Here it is. So we have to wait a bit. Do we have questions so far that we could answer in the meantime?
I think so. Let's see. No questions have been asked. So you're either blowing people away.
Let me maybe not. Let's look at the POM file in the meantime. It's a Maven project, so I will find all the dependencies in the POM XML. And yeah, I can see that we have several dependencies to Quarkus, all the different components, a health check. Oh, I know them. Small Rye. Isn't this a project from Microprofile, Mr. Subatomic?
It is.
So Quarkus actually implements Microprofile. That's cool.
You're absolutely right.
Wow.
So you're quite familiar with it, right?
Yeah, right. I've developed several projects with Microprofile before, running on a classical application server. So I'm very curious. I hope this will start soon. But we can also already have a look at the other commands. Oh, rsync. What is this, Mr. Subatomic? Why do we have rsync here? I know it to synchronize files.
Yeah, there's sometimes you want to kind of develop locally with your local IDE, like I don't know what you use, IntelliJ or Eclipse or something, and you probably want to kind of sync your with this server-side workspace. So this is why I have this rsync container component in there, so you could kind of work offline and sync your actual code then.
Okay. In the meantime, the service started and I clicked on this link, the right navigation, and I can see the service. It's actually started. Let me check some of the endpoints. Here's something for health checks. I can find the metrics. Nice, very nice. And the Swagger UI. So the car simulator has also REST interface. Let's try it out. Send a request. Oh, and it, okay, it gives me the route that is actually simulated. Nice, nice. So what I do next is I think I have to look at the code again. Oh, it's yellow. What's wrong with this code? Ah, there is something, an unnecessary import. So this will be my first commit. I will delete this, and I'm getting productive in the first 15 minutes. Great. Let me see. Git, where can I see my change? Stopping the service.
But hopefully you don't commit every import removal in general, right? So.
I can't see it yet. Perception service still running. Here it is. I have to stage it. Removed. Import. Commit. And push.
You know, the push is the one button I wish they would have out there to be like not in the sub menu, you know. I get it, they're working with limited space, but that would be the one button I would always have, you know.
But before I do the push, Mr. Subatomic told me that I should have a look at Openshift again, because whatever is triggered after this push must be here in this environment again. So let me look at the pipeline section. Bobbycar Dev is its own development project. There is a car simulation pipeline. Nice. And it's visualized actually. Cool. I can see the steps. So this should probably be triggered by my code push. So let's switch back. So I've pushed this to a registry, Git repository, sorry. And yeah, let's wait if something happens. In the meantime, there's something happening. Wow, a new pipeline run is starting. Cool. It's quite cool. It's animated.
Nice.
Git clone starts. Then we will have our unit tests running. Then we do Sonar scan. Oh, I know SonarCube from my previous job.
I love the pipeline, Tecton pipeline interface. It's just lovely.
And then we deploy the artifact. Yeah, it's so cool. You instantly understand what's happening, right?
Yeah. Don't be confused. There is a pipeline metrics tab. So if you go to the pipelines and there is a metrics tab, which is quite nice, but I just wanted to mention, don't be confused about the actual data is there, right? So our pipelines, they don't take 7 hours or something. So
No.
it's just to, but this is quite nice to see, okay, especially for me to see how long does it take and how it works.
But we have only 2 minutes, so
so I'm actually pushing back the meeting that I have, so feel free to take more time as you need.
Okay. So what I wanted to say is, so we've seen that there's SonarCube, that there's something like artifact push into some repository. So where can I find all the servers? Let's look at the pipeline. It's actually, again, YAML, as we all expected. And okay, the repository is somewhere in Openshift. Nice. And Nexus also in Openshift. So, okay, I can also see the namespace or project name, Bobbycar Dev. Yeah, so I'm in Bobbycar Dev. Let's have a look at the resources here. go to the topology. And yeah, the whole environment for our development is in Openshift again. Very nice. I have the Git repository where our source code can be found, and I see my commit, removed import, actually. Nice. Then we have Nexus. And we can find, I'm sure that we can find the artifacts here. Okay, the pipeline is still running, so I guess these are old ones, but ours should appear here. And we have SonarCube. Ah, nice. There is the analysis, and I hope we have only 9 code smells after that, because I've removed one, right? I've removed the unnecessary import. So let's give it some time. And yeah, I click on that because I'm curious. Oh, I can even see the logs of each step instantly. Okay, it's again downloading all the dependencies. Takes quite some time. Yeah, nice.
Yeah, it really looks great. Kali Native, you're doing great. Really, you're really doing great.
For my first 15 minutes, right?
Man, I have one question. So,
yeah.
As you're a Java developer, right? So, do you probably also have some experience with Apache Camel? Because in our Bobbycar context, all the integrations are built with Camel. So, there is also a workspace definition for Camel, and I'm just curious if you could also have a look there.
Yeah, I can try to. I don't know. Let's have a look. Ah, there's a second workspace. Let's switch to this one. Gonna refresh. So I can have several workspaces, right?
Right.
As a developer.
Mm-hmm.
That's cool.
As many as you need.
So you have to tell me what is happening here. So I have another workspace, and this one has more capabilities in terms of
it has different plugins. So for example, there is this Apache Camel K, let's say, plugin that helps you kind of developing Camel K integrations. And for example, there is, you also see the components, Bobbycar, where we have our all the Camel K integrations, like for example, the MPD, Kafka service and so on, right? And there's some integration in the IDE as well. So what you could do just to get started is, for example, I'm not sure if you have to log in kind of to the Bobbycar, for example, namespace or project where our actual project is running. Then you could see like the running integrations there. You could easily start a new integration. I'm not sure if you're logged in.
Of course, we give our developers admin access to everything.
Of course.
Only Kali Native.
I'm
only Kali Native. Fair enough. Fair enough. He's the architect of this whole thing.
Okay, I'm logged in. So
yeah, so basically you should be.
No, I can't.
Okay, but what you could do, just create a new integration.
Okay.
You could you go to the command, search for Camel K, and then you see, okay, what the plugin offers you, and
that one.
Create just a new integration file, and
nothing is happening.
Okay, so there seems to be something wrong with the environment.
Finally, so at the end of our demo, something should fail. Otherwise,
of course, something breaks.
Let's
fix it.
Won't believe us.
Okay.
Maybe restart the workspace. Mr.
Yeah.
Subatomic. Should I?
It definitely could help. I'm not sure what the problem actually is. Yeah, just stop and start it again. But I guess there is some connectivity issue with WebSockets or something.
Yeah, because
Offline.
it was inactive. Yeah.
There is, yeah. It looks like this. Yeah, okay, anyhow.
Let's give it a final try.
Yeah, and there's a question here in chat. I'll give it a while this is loading up. So, interesting project. I was going through the repo, and it is mentioned Bobbycar is a sample implementation of an IoT reference architecture. Is there a reference architecture being like, are you referring to another reference architecture here and just implementing it? Or is there some higher level thing that you could point to where it's like, this is a, this is our implementation of a reference architecture? And the answer can be no. That's totally fine. Like, this is our reference architecture for doing IoT kind of deal.
Yeah, I mean, there are different reference architectures out there, and they normally have kind of, let's say, 4 to 7 layers, if you want to say. And let's say they all have some things in common, right? So I'm referring to, let's say, a more or less general reference architecture. If you combine all the things you find out there, like, and also the examples from AWS, from Azure, and so on, and you see how the architecture looks like, and you kind of generalize what are the core components, what technology is behind that. So what is in common with these, and this is kind of the more or less generic reference architecture for an IoT, let's say IoT environment, where you have like cold path data processing, hot path, and so on, different streaming, and so on. And this is just one example of how you could build such a thing with Red Hat technologies. So I'm not referring kind of to specific reference architecture. And as far as I know, from the Red Hat side, we don't have like also a specific or a reference architecture regarding IoT. So
no, like we don't do reference architectures in general at Red Hat anymore, just for like, there's so many different scenarios now and so many different vendors that we hook up with. There's no one like cloud reference architecture. All the clouds are different. There's no one like on-prem architecture, because your premises, there could be varying things there that are different than what we would, suggest or do, if we were on site kind of thing. So general idea is this is a reference you can use to implement, in your environment. Cool. Any luck getting it working is the question.
Let's see.
Okay.
Oh, okay. This time it worked. The old workspace also said that it was offline, so there was a problem. So now we have created a new integration, right? I have Java code, very simple. There's a timer. Every second, I will trigger a route with the ID Java and log something out to level info. How can I run this, Mr. Subatomic?
Yeah, just run that to get you going in this Bobbycar environment. Yeah, exactly. Context menu, and then you could just start this Camel K integration. You see the last point there, right? Menu. And then you can specify the different options. So in dev mode. And if you then switch to the Openshift environment, for example, in the topology view, right, you should then see if the integration is coming up. You should also see it in the topology view.
Pipeline has finished now.
Okay, cool. Okay, cool.
Nice.
It was even successful. What a surprise.
Yeah.
Just,
okay.
Okay.
Okay. So
Can we see it? No.
Is it already running?
I was about to say,
No.
yeah.
It's just
deployed.
waiting.
Created.
Yeah. Now the thing is, you see right in the Bobbycar components repository what is checked out there, like the MQTT to Kafka and all the services. So what you could do, for example, which is quite nice, so you could really develop new versions by let's say in the in this. For example, in the production environment, even that is possible. So you could grab also the data. You could also subscribe to the MQTT and build your logic with the actual data coming in, right? So from in this production environment and test it there as well. Or so this is really a nice thing with
yeah, because if you are writing or implementing an integration, yeah, you need the targets and sources for the integration. And they are usually in the production environment or something near the production environment. So what I, as a developer, want to have is to have a possibility to push my piece of code here into that environment so that I can test the integration between the real services or the real integration points, right? And this is what is nice here. And I don't know why it takes so long. What we would see here is that, yeah, you could, for example, directly change the logic, and you would see that it would get redeployed instantly. So it's also a kind of live reloading, as you might know from Quarkus, for example. So you can
very fast in a loop developing in this context. But yeah, obviously there is something wrong. I'm not sure why it's not working. So, but yeah.
But we see our integration now here, but it's not working. So yeah.
Okay. Well, do we want to troubleshoot this? Do we want to wait? Do we want to push forward?
We can switch to the CLI, for example, and troubleshoot this. We can, for example, because it's installed via our operator, we have new custom resource definitions like an integration. We can have a look for all the integrations in this project. Okay, very slow. But I don't even see it.
Did you say you were resource constrained on this cluster?
Yeah.
Yeah. Okay.
How is it called? Ortwin kit? Yeah. It's very slow.
There is something very slow.
I was about to say something is going on.
We had clusters.
Yeah, we also had today, let's say, serious DNS problems. I'm not sure if there is something wrong again or in this cluster.
Maybe. I mean, it did come back with errors, so those last few kit things are errored out.
I cannot see it because once again.
Yeah.
It's so very slow. No. I want to see the time.
No, I don't see an integration kit from at all at the right time. So I don't think it's created. Yeah.
Yeah, looks like it's
not created. Okay.
Should I rerun this? I don't know. Is it a good idea?
You just try it, but
yeah.
What does it say? Starting new. Okay.
Technology executable, and it's asking you which config or
Dev
how to
mode
config. There you go. Okay. Updated.
says updated. Okay, but
All right.
let's see if there is something. I have an idea. Do we need to change the project? I didn't change the project before.
What
Oh,
project?
that's right.
Project are you in? Yeah, I mean, we definitely need the
We are
in the project, right?
in the code ready project. So I need to switch to.
You're not
to
in the
Bobby.
You're not in the Bobbycar project?
Nope.
Oh, okay.
This is the problem.
So what you could do is now you could in your code ready workspace project, you could also install the camel K operator to make it work in your let's say development environment. But yeah, if you're in if you don't have the camel K operator, then it's sure.
Yeah.
Work.
Yeah, and that's why I haven't seen
that's why
any
also
integration.
You didn't see the other
was
integrations from Bobbycar.
Yeah.
Okay.
There we go.
Okay, I was assuming you already
complaining. I haven't made an
integration
selection. Okay, but because I
there.
this
Okay.
now.
Okay. Now we should also see then in topology.
Now it should appear here, right?
Yeah.
Let me.
Yeah, it shows up here.
Mm-hmm.
Oh, okay.
Okay.
Yeah. Nice.
Yeah, no, you could just change something also, right? And
yeah, I will switch back. Sorry. Okay, so we can see now the output, hello world, hello camel K from Java. And we can just change this from Openshift TV. Now it's redeployed, rebuilt, and let's see. Well, oh,
yeah,
hello world from
Openshift TV.
It hates me.
I see it. But every new line, it takes you back to the left. Nice.
We still have fun, as you can see. So,
yeah. Now the other thing you could, just show one of the examples we have now. And this is not the hello world. So we could now, for example, the Kafka to data grid service, right? So we could have a look there. So this is the actual implementation where we do the zone changes, right, and the caching. So this is kind of the actual implementation we use here.
Yes, it has a lot of inner classes because we needed to do it in a single Java class. But
but the nice thing is really here we could start developing or extending it in this environment and test it with the data coming in and so on. So I think it's quite nice. So
and in the meantime it shows up here.
Yeah,
because I changed the project. Okay, this was my fault then.
These are the 4 running services we have right here. You just check the logs of one of them, right? So this should be now
follow log.
Yeah, and you see, okay, so these are the metrics and positions which are then exposed as WebSocket for the dashboard, right? Dashboard streaming, yeah. These are the running integrations.
Cool.
Nice.
This is the other integration. Yeah.
You're offline again.
I'm offline again. Okay, so I don't know what's
connectivity.
No, I'm online again. So, but I think in essence, this was our demo. I think we covered all parts. Now we had a human error, let's say.
Hey, it happens.
Yeah.
You know?
Yeah. But we found out how to fix that. We are at the end of our demo, and yeah, happy to wrap up.
Cool.
Maybe there are still some questions. I don't know
No.
what the audience says. I didn't follow.
Well, there's a question here about what is our Twitch channel address, but I'll just drop that into chat. But yeah,
Oh, I don't.
And they just found it right as I typed it. So cool. So yeah, thank you very much for this demo. Awesome integration of multiple cloud native capabilities here. Pipeline still running.
Yeah, we should also see that this is.
Yeah, check SonarCube.
Yeah.
So the
9 code smells. Yeah. So, and we should also have one here, but need to refresh, I think. Yeah. Number 6. So it's also released. So this is the proof that the pipeline actually did something. Yeah. Right. Yeah.
Nice. All right. Well, Carl, Native, and Mr. Subatomic, thank you very much for coming on the channel today. But seriously, Orwin, Ben, this is really cool stuff, right? Like, this architecture kind of blew my mind when I first saw it. So it was one of those things where it's like, I hope you go back and watch this if you missed something. And if you're watching it, you know, after the fact, after we're live, feel free to reach out to me if you have any questions, short@redhat.com, or you can find me on Twitter, just @ChrisShort with 2 S's. And yeah, I can get these, any questions you might have routed to the right people here. And yeah, coming up on the show in a little over a half hour, we're going to be talking about database disaster recovery with our friends from Crunchy Data. So please tune in for that. And don't forget to like, subscribe, and, you know, share if you so see fit. I always appreciate that from the audience. So yeah, if there's nothing else, Carl and Mr. Subatomic, I will sign off for now, and we'll catch up with you all here in a little bit. But thank you for coming on. This was an awesome demo. Just, you know, despite human error, that happens.
Thank you.
Thank you for having us.
All right.
Have a nice day.
Yeah, take it easy, everybody. Stay safe out there.